Okay, let's look at assignment A1-2, which is solving inequalities, and they're linear. So we're only going to have to graph them on one axis. So we've got our x-axis drawn on each one of these problems. So the first thing we're going to do is try to put all the variables on the left. So we're going to put the x's on the left, and then we'll have the inequality. And recall that if we have the variables on the left, that the direction of the inequality is actually going to tell us which direction to shade. So this one's pointing towards the left, and if you put the variables on the left and you end up with a greater than symbol, then we're going to do all of our shading to the right. So let's take a look at this first problem. First thing we need to do is distribute that positive 3 to both members, and we get what? 27x plus 12 is less than 35x minus 4. And so following our little rule, we're going to put the letters on the left, so we're going to subtract 35x from both sides, and we would get what? We're going to get a negative 8x, and at the same time we could also subtract our 12 so that we can set it up so the numbers will be on the right. Of course that goes to 0, and negative 4 take away 12 is going to give us a negative 16. Dividing both sides by negative is going to cause a couple things to happen. First thing, we're going to get positive x, and instead of less than, we're going to have to switch the direction of that inequality, make it greater than, and then negative 16 divided by negative 8 is going to give us a positive 2. So there's our answer, and all we have to do is identify where 2 is on the number line, and recall that we simply shade an open circle because it's just greater than, it's not greater than or equal to, and just shade towards the direction of the inequality, which is to the right. So we just shade the number line like so, and we'll move on to the next problem. The next problem, very similar. We're going to distribute that 4 to both terms inside the parentheses. We get 4x minus 28 and plus 6 is less than or equal to a 22. And here we can combine like terms on the same side. Those two are like terms. Negative 28 and 6 gives us a negative 22. And we still have our 4x over here. So now we're going to add 22 to both sides, and we're going to get 44, and we'll simply divide that by both sides by 4. We'll do it up here, so we have 4x divided by 4 less than or equal to 44 divided by 4, and we get x is less than or equal to 11. So we'll just say that's 0. 11 might be over here somewhere, and this one's going to be not an open circle but a shaded in circle, and we're simply going to shade in the direction of the inequality, which is to the left. Okay, let's take a look at an OR problem. This one is a disjunction problem because the inequalities are separated by OR. So typically what that means is we're going to have some shading going on to the right and another shading going on to the left. So let's set this one up just by solving them independently of each other. So we're going to add 1 to both sides, and we're going to get 6, and get an x over here. That's pretty much it for that one. So x has to be less than or equal to 6, And on the right, we're going to subtract 3, get 7. X is already solved for a single x. So the second direction is going to be starting to shade above or greater than where x is equal to 7. So let's just identify these two. That might be 6, and 7 might be right here. And we'll simply indicate that by drawing a closed circle. Closed circle for the 7. And we'll just shade this direction. And shade over here in this direction. And so that's an example of an OR problem. Let's do an AND problem. And an AND problem can be identified because you have an inequality and they're always going to be pointing in the same direction. And in order for this to be a valid AND equation, you're going to get your x term in the middle. Both arrows will typically point to the left, and you'll have a small number on the left, and you'll have your big variable or your big value on the right, and what you're shading is in between the small and the big number. So let's see if we can solve this one. So recall that we're solving two equations simultaneously, so we're going to have to add 2, not to one side, but to actually two sides. So we add 2 to both sides there. Negative 7 plus 2 gives me a negative 5. 5x is left there. And 3 plus 2 is 5. And notice that the inequalities are still pointing towards the left. Divide both sides by 5. That one by 5. And negative divided by positive is going to give me a negative 1. And inequality doesn't change signs because we divided by a positive 5. And we get x in the middle is less than 1. So this statement here says to graph everything that's in between a negative 1 and a positive 1. So just identify those on the number line. That would be 1. Notice that the inequality on the left is greater than or equal to 1. So that circle is going to have to be colored in. And on the right, it's just less than. And so we simply shade all the values that are in between those two identified endpoints. Okay, check back for another video, and hope this helped clear up any confusions you might have been having on this.